Hey all, I hope I'm audible and clear and you are able to see my screen. Can someone confirm please in the chat?
Yes, we can, Hari.
Thank you very much. Okay. In the interest of the recording, I just keep everyone on the mute. Okay. That doesn't mean that you need to wait till the class ends. Okay. You can simply text me on the chat. Okay. As and when you have any doubts, please post it in the chat channel. Hmm? Thank you very much. So, as a quick introduction that Hari here. Okay, I'm going to be your Power BI trainer. I'm a Microsoft Power BI data analyst certified PL300, right? So as you would have seen the class structure, right? The course content and all those things, that what are the topics we are covering. I will just give you a one small diagram now. Let me show you a small diagram. Yes. Okay. Now, if you see here, data to insights journey, right? This is our objective in a simple thing. So, what is our objective is we are going to learn the skill that is going to help present the huge amounts of data into nice visualization form. Okay, that is a Power BI tool where we are going to learn in our class, right? So, in the current world where everything is digitalized, right? If you see across our globe, not about globe, even if you see across our streets and everywhere, right? There is nothing manual. Everything is digitalized. Even if you see a small coffee shop, a small office setup, right? They would be having a laptop, tab, handheld devices, whatever it may be, right? And they tie up with Google so that they provide some cloud space and lot of open source means free of tools are there, so each business is using those tools and capturing their day-to-day transactions, right? So with that one we are having a huge amount of data is being generated in the organizations, so we just simply terming it as a data factory, right? Factories those generate products, so we call them as factory. So with the adopting of technology, there are a lot of data is being generated. But if we are seeing them as it is, then we won't be getting much of the insights, or we won't be getting what exactly happening, right? So in the market, there are some powerful business intelligence tools, Power BI, Tableau, right? And Amazon and Google are providing many open source systems, right? Those are going to help to convert these unrelated data into meaningful insights, visually immerse and insights. That is what we are going to learn, right? And why Power BI? Because in the market, we have two market leaders are there. One is Power BI and Tableau. Okay. Tableau is completely altogether have a different user interface, whereas Power BI is a Microsoft tool. Now, when we see the look and feel, the user interface of Power BI, right? Let me open that one in parallel. It looks like that, okay, we already seen this tool because it looks like a Microsoft Excel or PowerPoint. Suppose if I open a blank report, or let me open our previous class report. If you see the look and feel how the options are grouped. So if I put you Excel side by side or PowerPoint, they pretty look similar. People who are having hands-on experience on the Microsoft Office tools, right? They can easily start working with the Power BI tool also. Okay. As a trainer, what I'm going to make sure is to tell you, boss, Power BI is a simple Microsoft tool. Okay. This is how you need to start working it, and make sure that you are having hands-on experience on Power BI. Okay, so we are going to touch base a lot of things in the, even we are going also see AI visuals, artificial intelligence visuals. Okay, all these things we are going to touch, and we are going to present our data that is present in the database or files into a nice visualizations. Okay, this is our objective. Now, I just want to show you another image, right? If you see this particular thing, in the journey of data to insight, right? There are different stages are there. Now, many have a question, hey, do I need to learn everything? Uh, my honest answer is, we should be knowing, yes, how they work, but that doesn't mean that we need to have a in-depth understanding about all those tools, because in the market, we are having good number of tools, and definitely one person is not going to manage everything, right? So operational data we are going to see in the data warehousing, that when you say operational data, the data that is being generated day to day as a part of business activities, right? And those are stored in SQL database, Cosmos DB data, they would be stored in different databases, and that data is going to be ingested into the analytical systems, right? In our first class we are going to understand why, what is the operational systems, what is the analytical system, and what is the synergies between these two things. Okay, similarly Azure data lake, data warehouse, Databricks, so different tools are there, but our objective is learn data modeling and visualization. Just be clear in this one, because every student will get confused, what is the purpose of my learning, that is very important. Okay, the second thing is, whatever we are learning, are we putting 100% efforts to it? Okay, because organization needs skilled persons. Okay, there is a lot of openings, opportunities in the industry as there. What it needs is the skilled persons. So if you pick a Databricks tool, Azure Factory, just be highly skilled, learn more in detail of about it. Okay, at the same time, since we are part of this journey, we should be knowing what the other tool does. Okay, so now we are learning data modeling and visualization with the help of Power BI, right? This is going to be our major subject as a part of our 3 weeks course. Along with this one, we are also going to learn about the database and data warehousing concept. These are the two minor subjects for us. Okay, now if you see here, Power BI is going to be our major subject. At the same time, when we say that, hey, I'm SME expert in the Power BI, definitely database is going to be one of our source which provides the data. That means we should be having good understanding about the database in turn SQL, structured query language. And for that one, we have picked up PostgreSQL. PostgreSQL is a open source. Open source means it's free of cost. Okay, there are good number of database in Microsoft also, right? But my intention is, yes, we already learning one tool from the Microsoft, so let us learn one database outside of the Microsoft. Okay, and as a part of PostgreSQL, the main objective is about how to install the database, right? How to write the SQL queries. We are going to practice SQL query from very basics, understanding what are the basic elements needed to create a table, to insert data, or to modify the table, all these things. Okay, we are starting from the foundations, and slowly we will stop at the intermediate level. Okay, similarly, data warehousing is very important. So whenever we say I'm a data analyst, right? Or I'm a data engineer, or I'm a business analyst, it is very important why we are having data warehousing. right? It's not a big rocket science also. It is very simple, straightforward, right? Two great scientists are there. They introduced their theories, so we would be touch basing about those theories. Okay, so out of the 15 classes we are going to have, like 3 weeks, 3 5 15. First class we would be having data warehousing, 4 classes with PostgreSQL, and rest of the 10 classes we are going to cover Power BI, right? It's like 10%, 30%, and 60%. That is way I divided so that we have an end-to-end understanding about the data journey. Okay, I just don't want my students to jump into the Power BI and say, hey, there is a data, you pull it, you visualize it. No, we need to understand how the data is organized, right? What kind of different systems we can put the data and how we can connect from the data systems. Okay, so if you see here, there are different workloads are there. The workloads in terms, I mean, different solutions: data engineer, data factory, data science, data warehouse, databases. Okay, so in this we are touching data warehouse, database, and in depth we are going to the Power BI. Okay, and many students have that. I mean, want to learn everything, but my simple answer is, since you are new to IT, right? At the starting only, it is it is not possible to put our hat on all those things. Let us pick one thing. Okay, that should be our launchpad kind of thing. Learn as much as possible and crack a job. Once we are into the job, then slowly we can explore other areas also. Okay, that is where how the learning curve should go on. That is what I feel the right approach. Okay, any questions or queries with respect to our course content? Okay, see, when it comes to the data warehousing, PostgreSQL, data definition and data manipulation language, and we are going to learn more about Power BI installation, Power Query, Power. These are all different topics. Okay, as and when we are going to the topics, we are going. In terms of class, daily we are going to have 1 hour class at the same time. Okay, in India it is 6:30, and in UK, sorry, in US it is around 7 p.m. Okay, but just consider we would be starting the class 15 minutes earlier so that we can have a walkthrough section, doubts, any Q&A clarification, and all those things. Okay. At the same time, after the class, you can expect another 15 to 20 minutes. Okay. For the doubts and anything. So I would request you to daily keep 1.5 hours in your calendar for the class, especially. All the classes would be recorded and they would be uploaded into the YouTube, accessible to all the registered students, right? So which means that you can watch the class recording anytime. Okay, and I'm going to give you the project task after the class. What I am looking from your side is that once today's class is completed, make sure by before coming to the tomorrow's class that you are having once again revision of the class and start working on the all the project task. Okay, that is very important. Why I'm saying this one is because just for your information, let me show you. Suppose if you take this is the Power BI, right? So today we would be practicing of creating this kind of visuals and everything. And in the next day, we would be start working another visualization, right? And if I show you the first visual, and if you go with the formatting stuff, there are different options are there, right? So you should be having some good hands-on with these options because Again, when I go to the next class and when I'm practicing with this matrix visual, right? These are all options are going to come again. Okay. The good thing with Power BI is whatever you learn in today's class, definitely 30% is going to repeat in the next class. Okay. So if you done a good hands-on practice and come to the class next day, the next class would be more and more easy. Okay. Lot of things are there. If you see the AI, right? If I type something, say total revenue, see, these are like artificial intelligence visuals, those are going to give. We are going to drag and drop, do manually. At the same time, we are going to learn about artificial intelligence, total revenue by products. See, so we are going to learn the tools, those are going to create required visualizations by just typing in the natural language. We are going to cover one by one. But since AI visuals are like advanced topics, they come at the last part of the course. Trend analysis, right? We do the trends, whether the sales are going upward, whether the sales are going downward, right? And we have different options to check all these things. So analyticals, a trend line, constant line, minimum line, maximum line, average, all these things are there. And we do lot of slicing and dicing. Suppose I want to know about the Australia sales. Just we will select the Australia country and we will see what are all different employees has done their sales for Australia country, USA, Canada. Right? These the if you see the all other visuals are changing. This is called the interactive, right? The interaction, cross interaction, or we also called it as a cross filtering. We are going to learn about all these things slowly one by one, right? Coming to the job opportunities, let me open this portal. Power BI jobs in US for entry level. I'm honestly just going with the entry level. Hmm? LinkedIn page where it is 479, it is showing. Yeah. Power BI instructor, I think this is for me. It is opened India. Let me put it USA. Almost 12,000 jobs are showing in the list, but definitely there is a filtration is needed. A Power BI report developer, you will be self-starter with a passion of data, comfortable working with cross-functional team to gather requirements and develop solutions, right? Skills required. There are a lot of SQL. Okay, this is what we are going to learn. SaaS Enterprise, this is something different, but again, Power BI apps. Okay, so as a part of this role, we are going to sure learn SQL and Power BI, right? How we are going to mitigate the one that is not aware, that by making sure that we are having in-depth knowledge from Power BI and the SQL and about the data warehouse concept. Okay, so pay range for the position $65 to $78 per hour. See, data analyst, finance, collaborate with financial and cross-functional teams, bachelor degree, right? Modern, this is a different one. Let us see what are all there. Power BI technical lead. Lead, design, develop, implement the company's BI architecture, develop and maintain technical roadmap for Power BI implementation, design scalable and performance semantic model for future, right? Technical authority. So there are good amount of these are going to guide the users in advanced Power BI features such as DAX, custom visualization, and Power Query. All these we are going to cover in our course content. Okay. Strong understanding about data warehousing concepts. This is what we are going to touch base. ELT or ETL process understanding, right? Knowledge about the SQL servers. So entry level associate. Okay. A good openings are there. It's just about leveling, skilling ourselves to the market requirements. Okay. And also the good thing with Power BI is it is mainly look and feel and everything is like a Microsoft Office tool. If I can see the PowerPoint or Excel, if I put side by side, let me show you the Excel. See, like in Excel, how we have the options. When you click on insert, we would be having all the different charts are there, right? Same thing here also. We would be having different charts and everything, right? So easy to learn. Okay. Only the requirement is that we should be having a continuous practice on the course. Okay. Any other questions? So let me pause the class. Hey all, once again, can you confirm that you are able to see the screen and I am audible and clear? Okay, thank you. So now coming to the data warehousing introduction, right? Sorry. So let me come back to the diagram that I have shown you. Yeah. Now in this data factory, right, there would be different technologies and systems can be used. It can be a files, it can be a database, it can be a Hadoop system, so whatever it may be. Okay, within the data factory. Now, when we say data factory, right, it can be the operational systems. Here you can see, right? The operational systems are generating huge amounts of data day to day. Now, when you say operational systems, these are going to serve the business directly. Now, when you go to the Walmart, right? uh, when you just taken all the required items and when you go to the cash counter, they simply ask you, can you provide your contact number? As in when we provide our contact number, right, they quickly get some basic information about us. The reason because is they already would have saved our information. Now, out of the millions of records customers they have, right? They are looking for one record that should fetch very quickly within fraction of seconds, right? If it is beyond seconds, then definitely the queue will increase with every minute, right? So the purpose, the main objective of operational systems is that they should be having capability of retrieving small amount of data. When I say small amount of data, one record for one customer, but very faster. Okay. Now, this is the solution that is going to work day to day. Now, at the same time, since there is a huge amount of data is being generated, what is the business, or like technology guys said that, hey, let us do some analysis on the systems. Okay, so let us see how many customers we have, how much profit we have got it, right? So then what happen is, suppose if you have a table of 1 million and if you want to know how many customers are there, then you need to count, right? Each and every record of customer table. That means I need to scan entire table, right? Check who are all active customers and then count them. So there is a lot of processing time and processing capacity is required. Now, if I am doing this exercise also on the same operational database, initially it is fine, no issues. But as and when data is growing on, right, there is a performance issues started coming because the same system is serving the front end clients to retrieve the data faster. At the same time, at the back end or in the IT room, some IT guys are doing some running some huge queries to understand what is our sales, what is our profit and loss, all those things. Now, at some point of time, this resulted in performance issues of both of them, both the teams, the front end team and the back end team. So that is the reason to handle this situation, right? The data warehousing concept has came. Now let me show you a simple diagram. Okay, very simple one, easy to understand. Insert online picture, the data warehouse. Very oldest one, but definitely intact. A simple one also, easy to understand, right? Now coming to our example, right? So the front end systems or online systems, they are putting their queries to retrieve the customer information. At the same time, when the analytical teams are hitting the same databases, right, or systems, then performance has degraded, right? So two great scientists, Rolf Kimball and Inmon, right? So what they decided is, okay, let us keep these operational systems, right, term as online transactional processing systems, transactional processing systems, right? OLTP. Okay, this terminology we should be remembering. Okay, the very important this is merchant center. Hmm? And use these systems only for the online processing only for the business processing. Don't do any analytics, right? So at the end of the day, once your business is closed, just take a copy of whatever the changes happen. Just remember this point, changes happen. Suppose today 10 records are loaded. Those 10 records would be taken a copy. Okay. Again, tomorrow, out of these 10, only 5 records got the updates. Okay. That means only 5 customers again visited and they have done some purchase. So there is a change in these 5 customers, right? Then only those 5 customers information would be captured. That is called CDC, change data capture, right? And store all this information in the warehouse. Now we all have heard about the warehouses, right? In the companies, a warehouse can be used to store the raw data or a finished goods, right? Whatever it may be. And it can be of different sizes, shapes based on our requirement, right? If it was a small organization, then we would be having a small warehouse, or sometimes a warehouse would be within the factory somewhere near, or sometimes warehouse would be somewhere in between the factory and the end users, right? Like that. Same thing happens here. So daily at the end of the day, one copy is going to be taken and we are storing in the warehouse. And how we are storing in the warehouse? In the raw data and summarized data and also metadata. Now, when you say raw data means exactly like to like copy. So in future, if I got a new requirement, say as of now, I am just collecting the summarized data, daily, say daily profit, or I would say daily revenue. I'm just storing one value that tells which is having the business date and what is the total profit, summarized data. Now, in future, if I get a requirement that I want to store the rolling revenues of month wise also, then I can refer again this raw data, right? And create one more summarized data element, right? So that is the reason we are keeping the data in the raw form as it is and also summarize data based on the business requirements. Business may says that I want the daily revenue information, monthly revenue information, quarterly, like that. And metadata. Metadata means information about what data you are storing. Okay, because in big organizations, it is very important that we need to report regulatories also. Sorry, that what kind of customer information are we storing, right? If regulatory says that as an organization that you are supposed to store customer name and address, right? And their telephone number. Then we need to make sure that we need to prove to the regulatories also, yes, I am only storing this information. Even though I am capturing few more details for other reasons, but I'm just dropping that information. I'm just only capturing the required information. So that kind of audits and everything would be kept in the metadata. Okay. So a data warehouse acts as a single point of truth, right? To maintain the historic data, right? To get the analytics of the information, and at the same time, it splits the online processing into the analytical processing, right? So we call this as online analytical processing systems, OLAP, right? And this concept is not going to change whatever the technologies or tools we are using. The ultimate goal is data would be generating. We are going to take a copy, right? And we store in the data warehouse, right? And again, once we created a warehouse, we are going to take data marts. What is data mart? Data mart is again a warehouse. Okay, it is going to have all the features that is going to have a data warehouse, but it's a subset of data warehouse. Say for my organization, Walmart, I have filled a data warehouse, right? But within that one, there would be inventory, sales, and purchase department. They really don't need to have access to the entire organization data. So in that case, what we will do is we will create a views. Okay. When we say views, they are like a copies of existing table. They physically don't there, but they are logical names of the physical tables. We are having a one topic called views. When it comes, I am going to show you that one. Okay. So when it comes to the just theoretically, right? I have a article from the AWS. Right? A data warehouse is a central repository of information that can be analyzed to make informed decisions. Okay. All the business users, right? The people who make the strategic decisions, analytics, they rely on data warehousing. And the terms like data injection, ETL, extract, transform, load, right? All these are managed by data engineers, and they are going to load the data into the warehouse, and they would give us the exposure, the Power BI data analyst and business analyst. Okay. And our success factor depends upon how accurately we are understanding the data model that is provided by the data engineers, right? Data flows into data warehouse from transactional systems, relational databases, and other sources, right? Business analysts, data engineers, data scientists, decision makers. If you see, these names can also be interchanged. Some organization, right? These roles are performed by the same people based on the level of skill they have. Okay. The makers access data through business intelligence tools, SQL clients, and other. Right. I'm not going to go the theoretical part of it, but the key points: informed decision making, consolidated data from many sources. Now, if you see here, right, there would be system, HR system would be there, finance system would be there. Similarly, some third party system where we are going to get some information day to day. All those data would be centralized in the data warehouse, right? That's what consolidated data from many sources, historical data analysis, data quality, consistency, accuracy. This is very, very important. Okay. Even when we are pulling data into the Power BI, right? Uh, we have some tools, data quality tools. Let me show you that one. Transform data. We term here that as a data profiling. Let it be open. Where is this one? View, see, data preview, right? So we can see how many valid records are there, empty records are there, right? These are options are there. Just we can select those options and check, and we can see what is a column profile. So these kind of a quick insights we have those options. Power BI has those options, right? Because the success of a Power BI developer is almost 50% depends upon how accurately data is there and how we are understanding the data more in detail. Separation of analytical processing from transactional databases, which improves performance of both the system. This is what one of the important thing, right? Separation of analytical processing from transactionals, which improves performance of both the systems, right? Now, when you say the data warehouses, right? Data warehouses are nothing but, again, they are also a databases only. But the databases, if they are used for analytical purpose, then they call it as data warehouses. Okay. Now, I just want to show you a simple thing. What comes in your mind when you heard the word about database? Anyone? You can post it in the chat channel. I can see messages are coming. Save. Desktop. Storage, data information, availability, a collection of data. Thank you very much. Thanks for these things, right? Hmm. Normally, when I feel the database, right, I compare it with my house. Okay. I'm just putting one shape here. This is the right? The shape that we use when you want to represent a database, right? Now, what I feel is that, like how we have our house, right? Whenever we would be there, we are in a house. Now, database is like a house, right? Where we would be having different rooms. Like within the house, like we have different rooms. The purpose is we want to make sure that the things that we use, they are organized in a way so that whenever we want them, we can quickly grab it. A kitchen, a bedroom, living room, right? It is for our to make our life easy. Similarly, when a database is created, right, it is not going to live as it is. Within the database, right, we are going to have tables. Now we are going to store, create, like how we create rooms, we create different tables in the database, right? The first table would be used to store the customer information. The second table would be used to store the product information, right? And third one would be used for the sales. And when we say sales, obviously the sales table should be referring to the customer and product details. So there would be a relationship added, like how our rooms are interconnected to the doors. Okay. Similarly, these tables are connected. That is the reason we call them as a relational database management system. Okay. And how they are connected? They are connected through the primary and foreign keys. We are going to learn more when we are in our next upcoming classes. Okay. But these simple concepts, keep in mind that a database works like a house, and within that, I'm going to have different tables. And we, as a data analyst, we should be knowing whenever I'm storing a data into the table, why I'm storing. Okay. Why a specific table for the products? Why I should be having a separate table for the customers? Okay. How these are correlated, right? We should be putting these questions to ourselves and getting the answers also. Okay. So that is all about data warehousing, and we have seen OLTP and OLAP, right? Now, WH Inman and Rolf Kimball, right? They are the two great scientists, right? So they have introduced the theory of data warehousing. Okay. And what is the theory they proposed? Let me show you some diagrams because it is easy to quickly understand when we see a diagram, right? Yes. So the information in the house must be related. Yes, obviously, they should be related to each other, right? Now, if you see the Kimball, right? What Kimball has suggested is, boss, in your organization, data would be generated from different sources. Say you are going to have a HR system, they are going to maintain HR department. They would be having some HR system. A finance department would be maintaining some tally software, right? Similarly, an inventory, sorry, manufacturing office would be having their own softwares. Sorry, guys. All these systems are going to generate a lot of data. Now, what Kimball says is that create, say, separate data mart. Data mart means it's again a data warehouse, right? Don't club everything like a scrum. Within the scrum, right? If you remember uh, the scrum, what it says, just break the things into the actionable uh, business outcomes, right? Then start working on, deliver the solution, right? Give it to the customer, take the feedback, and go in a iterative process. Correct? If I'm saying correctly, hope I need some Scrum students also here to help me. Similarly, what Kimball has proposed is start creating data mart for each and every department. Okay. Once it is done, then integrate to the overall organization data warehousing. Then on top of this one, whatever the reporting visualization required, create those things. Okay. This is what Kimball has proposed. An iterative, um, slow process. I would say slow process, but a iterative process. Right. On the vice versa, let me show what Inmon has proposed. Get all the systems into the data warehouse. Okay. I don't want a separate data marts being created. Okay. If I have 100 systems, those are generating the data in my organizations. Simply get all those systems onto the single platform. We also term it as a like enterprise data warehousing, right? And then once you created the data warehouse, then give a copy. Suppose if a HR department comes, just give a copy whatever they really need, right? A finance department, they may require about the salaries and all those things, the purchase orders, all that kind of information. Then give a copy to them. So this is what Inmon has proposed. Inmon's proposal is like a top-down approach. At the enterprise level, build our warehouse and then give the separate copies to individual departments. Okay. Now, just a simple question. Which solution do you think is the best one? Is it Rolf solution or Inmon? Kimball solution or Inmon? Even after the class, you are going to go back and go through these details and come up with me, huh? Okay. Uh, Kimball is the one that is getting more votes, right? There is no hard and fast rule, okay? Because these are almost proposed or these came in existence in 1990s, right? But still we are reading both means definitely both of them are being extensively used in the industry. Even my organization at this point of time, we are also creating one data lake, right? Data lake where we are getting all the systems into one place and creating a bigger data warehouse. Okay. Let us see the comparative things. Which one? And these are like a Newton law. See, in the science, we all know, right? Newton laws, more famous one. How they are still intact, right? And still everyone learns. Similarly, in the data world, right? We should be having a clear understanding about these two approaches. Because whatever the organizations use new technologies and everything, but the theory or the concept is going to be the same thing, whether they want to go with the Kimball approach or Inmon approach. It's about which tool they are going to use, which database they are going to use it. That's it. Hmm? Sorry. So just a comparative thing table, okay, to give us a quick insights. If you see in terms of approach, it has a bottom-up approach for the implementation, right? For each and we would be start working with each and every department from the bottom, and then we will go to the top. And Inmon is a vice versa. It's a top-down approach, right? Data integration. It focus on individual business areas. We would be sitting with each and every business area, understand their business, and start building solution for them. Correct? Whereas the Inmon is an enterprise-wide area, right? Build time, it is efficient and take less time, obviously, because I should be sitting with one department or one team, get the insights and start building it. It's a complex and consumes a lot of time, right? Obviously, it's simple and self-explanatory. It has a iterative cost and cost effective, obviously. Initial cost is huge and the development cost is low. See, this is where the Inmon has the upper hand. Initial cost is huge. The reason because is we need to get all the teams, right? All the experts, right? And also who has the knowledge of integration between these departments, right? So initial cost is used. But once we have design is finalized, right? Then the development cost won't be much of it. It does not need such a skill, but a generic team will do, obviously. It needs a specialized skill to make work because how these are how these would be different departments are there, right? So how HR and finance department is related, how the manufacturing and HR department is related, right? So this kind of specialized skill to be there. Here maintenance is difficult. If you see Kimball, the maintenance is difficult. The reason because is right, if we are go on creating multiple data marts, right? Suppose if I started working for HR department, there is employee table would be created. Similarly, when we go for the manufacturing department, right? There also there would be another employee table would be created because their department also having the employees. And when we go to the next department, there also we should be creating an employee department. That means within the organizations, we end up with creating multiple employee tables, right? So that is the reason Kimball's maintenance is difficult, right? Whereas in Mon, the maintenance is easy because at one shot we are creating a single employee table and we are going to give that employee table access to all the departments, right? Data model. This is very important, guys. I need at least 15 minutes of your time, very attentive, okay? Because the topic that we are going to cover is going to travel along with us, okay? The more we understand about this one, the upcoming class would be more and more easy, right? So I want you all of your attention for next 15 minutes without any disturbances, okay? So please keep your phones and everything silent. It prefers data to be in the denormalized form, right? Whereas the inmon, what it says, it needs, sorry, yeah, it prefers data to be a normalized model. Now, what it mean by denormalized and normalized? Okay, so for this one, I have created one Excel sheet with two tables. Let me open that one, right? I'm just showing multiple tables, not two different tables. Are you able to see? The first table is of a denormalized form. Now, how we are saying it a denormalized form? Now, if you see here, it's a sales table. We are having a transactions, right? And a detailed information about each and every transactions, right? Will you agree with me? The table is having a detailed information about all the transactions and moreover information related to the customer who has purchased or the products what he has purchased. Okay. Now let us consider if this Harish or Michael regularly visiting this store, right? At 10 times to same store. All the 10 times the address would be stored. And which means that we are storing data redundantly. Every time customer comes, his address would be stored. Whatever the products he is purchasing, that those product related information is stored, right? Now, a denormalized form is that means we are storing the maximum information required in a single table. Okay. And what is the concerns here is the data redundancy, right? Think of it, if we are having a uh, store, right, within a Texas city where you would be having hundreds of customers who repeatedly visit that store. So every time we would be storing their information, right? What is the benefit of this one is the data retrieval would be faster because your entire data is present in a single table. So as and when we fire a query, it is going to search from the single table and pull the data, right? Now, what is that? In the analytical system, it is decided if we are going on storing as it is, then we end up with paying lot of money just for the procuring the space. And in turn, it is going to not give any real business value, right? Will you agree with me, team? So a normalized form has finalized. So what it means is that we logically split the data into multiple tables, right? When we say logically we split the data means, okay, for the customers, I'm going to create a customer table. Okay. For the product, I'm going to create a product table. Now here I'm going to store the unique value. Say if Harish is there, Harish one record, his address and everything would be stored. Michael, Derek, only one time entry. Now whenever Harish or Michael comes to the purchase, right, I'm going to store his address unique identifier in the sales table, right? Now if you see here, instead of storing 20 or 30 characters, I'm just storing one unique reference ID. So which means the overall space consumption is exponentially reduced. Will you agree with me or not? Right? So the process of redistributing the data into multiple tables logically, okay? It's not like that, okay, I have I have 10 columns here, right? I will put first two columns in one table, second two columns in another table, not like that. Okay? Like, okay, I know that I want to store the product information, customer information. That means I create a table, product table. Okay. Now here the product ID is going to be uniquely represent one row. Okay. So that whenever I use this product ID in the transaction table, right, it is going to fetch the unique record. And this relationship is called primary foreign key relation. Okay. The product ID in the products table is going to be a primary key. Okay. So we should be learning what it means by primary key means a key that is unique and not null. Okay. That will be used to uniquely identify a single record in the table. Okay. Now, when this primary key is used in the sales table, then we call it as a foreign key. Is a foreigner here. Okay. Yeah, I'm going to repeat the whole concept, right? And how this looks like, let me show you one diagram to give a nice picture about it. And this diagram is from, again, our Microsoft Power BI itself. Here it is. Okay. So here our entire sales data, which is present in one table, now we are going to distribute that one. How we are going to distribute that? The product related information we are going to store in the products table. Employees related information we are going to store in the employee table, right? Similarly, the reseller and the sales table is going to refer their primary keys. Okay. And these tables which are storing a detailed information, we term them as a dimension tables. Like if you take any shape, right? We call what is its dimensions, length, breadth, height, right? If you take a square, what is its dimensions, sides? If you take a rectangle, what is its dimensions, length, breadth? Similarly, for this sales table or fact table, right? Why we are calling it as fact table? Because if a transaction is happened, right? It's a fact, an activity is performed. I'm going to capture that information. Say employee has sold product XYZ to customer. Now in the sales table, we are going to store the reference numbers of the employee, product, and what amounts they have stored. Okay, that's what here. See, a normalization is the term used to describe the data stored in a way that reduces repetition data. Okay, consider a table, just they have given the example that we discussed, right? Instead of storing this product information repeatedly, right? We are going to store just a their key here. That is normalization. Okay. Now, since this relation looks like a star, we call it as a star schema. Okay. Now, when a fact table is referring, right, to any particular product, right, there should be only one record, or else it would be end up with pulling multiple, not sure which one to be accurate one. Okay. So the fact table sitting at the center, that is going to hold all the facts, like it can be a sales or observations, right? And it is going to store the key values from the dimension tables, so that whenever fact table need more information about those products or employees, then it is going to refer to the dimension tables. A well-structured model design includes tables that are either dimension tables or fact tables. Avoid mixing of two types together for a single table. Okay. So this facts and dimension table, right, or star schema, right, we should be very clear, crystal clear. What I would suggest is, if you have any doubts, we can repeat again and again, right? But at the end of the day, you should have a clear picture. Okay. If I have a business, like how I'm going to create, what are the dimension tables I'm supposed to create? What should be the fact table? Right? What even Power BI says that it can't manage with the single table, right? It also needs this normalized form of data model so that it can present the visualizations very easily. Okay. Any questions or queries? So this is a star schema, right? Sit, fact table sitting at the center and surrounded by the dimension table. I mean, these are like a reference tables, okay, where you would be have further more details. So if you see here, my transaction table is going to have transaction ID and production ID, customer IDs, right? So this information would be there. But if I want to know what exactly this product means, then I would be referring the products table for more details. Okay. Similarly, this fact table is going to be used for summarization. Okay. Like How many total quantities are sold? What is the total cost? Cancel. Okay. Whereas the dimension tables would be used for the filtering, where product is laptop, where product is food items, all those things. Is it like a indexing? Yeah, it's like a referring, Sinota. Yeah, like referring that yes, I store more details in the dimension table, and whenever I need extra information, then I will come back to the dimension table. Okay. And how this relationship is created, we are going to learn when we are learning about the constraints. Okay. Why? Because suppose if I am storing a product one to something, right? Obviously, the information related to be product table should be present in the dimension table. Then only we should be loading that product into the sales, right? So those things we would be further deep learning. Now this single level, right? One step is called a star schema. Okay. Now there are scenarios where this dimension table further refers another dimension table. Okay. So one classic example is for the address table. Now if you see here, we have the customer address dimension table where I am storing the customer addresses, right? Now in this we have a city and state column. Now what happen is we know, right? Within the city we are going to have hundreds of customers. That means every time city name, state name, city name, they are going to be repeated. Why to repeat? I will create a city table with just one entry for city, and I will use this unique ID to represent in the city ID column. So that means the dimension table further referring city table, another dimension table. So this is called snowflakes. Okay. I mean, having two levels. Okay. So if you are having only single level, one star and surrounded by dimension, then we call it as a star. But there is a business requirement comes, some dimension table also refers, right? Another dimension table. So that we call as snowflake schema. Okay. So this is all about star and snowflake schema. I'm going to share all these information, knowledge articles that I would request you to please read these knowledge articles so that it would be very easy for you to understand. Okay, guys, at the end of the class, what I normally do is the class recording link and the knowledge links, right? All these knowledge links which I have shown you, and along with couple of project activities, I would be getting a mail. Okay. And another mail with all the AI generated meeting summary. Okay. So I would request you to please keep these two mails in a separate folder so that you can quickly refer them when you are going to start practicing. Okay. Fine. So data systems, source systems are highly stable and these source systems have high rate of change. Obviously, we would be getting more and more source systems, right? Fine. We have covered introduction, we have covered OLTP and OLAP, and we have seen the Inmon and Kimball theories, what they proposed, data mart, data warehousing, and normalization and dimensions and facts. Okay, so we have covered pretty all the topics from the data warehousing, right? Our first class. So let me pause the class here. Okay, so denormalization. Now, in the normalization, if you see, right, this table, right, here instead of storing the complete details about the customers or product, right, I'm going to store their unique IDs. right? Now, where I'm going to get this one is before starting loading the sales table, respective dimension tables would be loaded with that information. Say, take an organization. Okay, if they want to introduce a new product, suppose say I have a store, right? Now I want to sell the laptops. First, what I need to do, I need to load the laptop related information in the products table. Correct? So I would be having a products dimension table. Where it is, this one. Yeah. Yeah. I would be having a products dimension table. Okay. In that, I will make sure all the relevant information about that product is stored. Okay. So this becomes as a dimension. Now this dimension table will be used whenever a sales table, I mean, whenever we do a sales. Now I have started sales, right? So someone come and ask me, hey, I need a laptop. Then immediately I search whether the laptop is there. Yes, if it is there, then if the deal is okay, then we do an entry with the laptop details. Now here in this entry, we are going to just store the product unique ID. If this two is not present here, then we won't be able to enter these two into the fact table. So that means whenever we are doing data analysis, right? So if you need laptop information about it, then this product ID column where two is there, it is going to refer the product table and get full details about the laptop, right? In this way, data is stored in multiple tables as a normalized form. Okay. And if there is only one level of relation, each fact table is connected with only dimension table, right? And these dimension tables are not having any further relation, then we call it as a star schema. Okay.